Hello and welcome everyone. We're really excited to have everyone here today for our weekly OCI deep dive. I'm Maria Philipp, Product Marketing Manager with the OCI Go-to-Market team. And today we're joined by presenter Paolucci, Data Development Specialist for Oracle EMEA, and he'll take you through presentation and demo. We also have Sonja Meyer, who is Q&A lead for this webinar. She's also Data Development Specialist for Oracle EMEA. Feel free to raise any questions in the Q&A box at any time during the webinar. The topic of today's webinar is SQL and Autonomous Database, a Rockin experience, where you learn about hands-on powerful autonomous database action tools and Oracle SQL knowledge and adoption by using music as a real-life scenario. Go from initial entity and relationship idea to data loading into autonomous database to integrity referential constraints and first entity relationship model with the music topic. This is it for me. I'm going to turn it over to Paolo now. So please, Paolo, please go ahead and take it away. Thank you.
Okay, thank you, Maria. Good morning, everybody. I'm Paolo Paolucci from Oracle EMEA Data Development Specialist team. Welcome to this Cloud Customer Connect called SQL and Autonomous Database Rocking Experience. It has to do with interesting, useful, and funny topics. Well, what we want to do in this demo is to start an experience of building a data model on autonomous database, encouraging the discovery and adoption of the autonomous database, SQL powerful tool and language, powerful tools and language by making use of a real scenario data topic example, music, let's say rock music topic. So our purpose here is to introduce you to the knowledge and adoption of the Oracle SQL, Oracle Autonomous Database using rock music as a real-life scenario. And of course, in this Cloud Customer Connection session, we cover a list of steps in developing the environment. We do the data loading to Autonomous Database. We do some data table structures manipulations. We create the referential integrity constraints between and among the tables, and we'll end up with a first version of an entity relationship model, the data model on our database. Okay. Of course, Sonja Meyer is alongside me in doing the Q&A. So, why we want to dive into the Rockin side of SQL and Autonomous Database? Well, we have musicians, we have album records, we have concerts, songs, and so on, whatever other information. What we have to do with SQL and Autonomous Database? We could say apparently nothing. Well, just because I was looking for a valuable source of data to use as a scenario example for data loading onto Autonomous Database and data handling. And so I explored the vastity of music discography. Just then focusing on few of my best favorite ones. So just to say that there are so many sources to look for information about rock music topic and so on. Very interesting information that we can load into database tables, we can handle with, can perform interesting queries with sample data coming from the real life. And real life is more complex than the sample data we have in our demos, not only in our database and so on. So we have plenty of this information that can be retrieved, collected, and loaded into a database in an organized set of data. Just some thought about information we can search for: artists, information, and nationalities, the albums and singles that were published during their career and which position they achieved in top chart, and many other interesting information, of course. So this is a data searching process for which we have, for the sake of demo and simplicity, manually collected music into Excel, CSV, JSON files that are ready, or let me say almost ready, to be loaded into a database. So for the sake of demo simplicity, we collected a small subset amount of this vastity music topic that we could potentially collect. Let me say this is better than dealing with the well-known department employee job data, usual data set example scenario. Well, we call SQL an Autonomous Database Rocking Experience journey, this one. Just because it is a journey a flow we do, let me say. We start with finding and collecting the music topic data content into source files, like we said before, JSON, CSV, Excel file, and so on. We did just for assuming having manual data collection for now. Okay, we conceptualize. We start creating the concepts of the data modeling based on the sort of information we want to collect. So, which kind of entities we want to define, and which are the association between them we want to create. We are preparing the ground for the entity relationship model. And then, of course, we do our first data loading into autonomous database by using the autonomous database user interface tools. And then we start doing some SQL discovery. From a practical standpoint, what we do is we load the data. We do some handling of the table data content. That means we do some modifications on data values. We do some from the SQL point of view, data manipulation language activities. We do then some handling table data structures. That means we handle the table object itself with some data definition language activities. And then we do some the most important ones, I think. We add the integrity and referential constraints with these tables in order to complete at least the first version of our data model, entity relationship data model. All these steps will be done by using autonomous database user interface tools. But of course, underneath all these actions is there's always SQL doing this, let me say. Well, before putting into practice, I started with modeling the data source entities, let me say, looking for several information. And while looking at this source of information, I started thinking about how to create my model, how to make the associations between this information by making myself some questions. For example, the first intuitive one for me was about the first one. Find me which albums of a given artist as a given song X, as a single. Okay, so given that a single belongs, it is not always in this way, but we keep it simple. A single belongs to an album, and a given album can have more than one album record, can have more than one single. So the first entity association or entity relationship association that can imagine is a one-to-many between these two entities. Have another one. Which songs were performed by a given artist in a given location in a given date? Example, which songs were performed by Jimi Hendrix at Madison Square Garden in January 1970, just for example. Well, a given concert, given a concert event, I have a location, I have the date of the concert, I have can be a ballroom, can be a stadium, and so on. We can find details of the list of the songs performed in that concert, the set list. So the immediate association for me will be a one-to-many, because I have a concert that has more than one song performed in that concert. But however, if the question was, in which concerts was a given song Y performed? For example, in which concerts was performed Foxy Lady song was performed, or Whole a Lot of Love of Led Zeppelin? Okay, here the association would seem more a many-to-many, because of course a given song is performed in multiple concerts, and of course a concert has multiple songs. So these are the first entities for which I've collected the source of data to create my data model. And so I have the entities are the artists, I have the albums, I have the singles, concerts, and so on. That could be more, but we just skip to this perimeter to keep it simple, of course. As mentioned, the data source information have been collected into Excel, as you can see from some examples here, CSV, JSON file, and so on. And here, for example, we have some portion for some excerpts of the following of the Excel files about the artist entity, the albums entity, and the singles. In this case, you see, even I assumed this. I've already collected in these entities what will be the unique attributes identifier for each entity. So, for example, I have an entity in my artist entity. I have the artist ID pre-collected with unique values. And the same for the album ID, the albums, so the album ID, and for the singles, the single ID. But I also added, especially in the singles and the albums entities, two more reference attributes. So, for example, for the albums, I collected also the artist ID referencing to the artist for which the albums belong. The album belongs, and of course for the singles. Given a single can belong to an album, and the same, an album belong to a given artist. So we are preparing the ground for the parent-child association between the future tables we'll have starting from these entities. So, which tools and resources we are going to use in order to start our data population on database? We have an autonomous database instance. Autonomous database, it is an autonomous database shared transaction processing. We have a set of tools called the database actions tools. It is called even a SQL Developer Web. It is also called, and it is a set of tools which provides all the necessary development tools, the data tools, the administration and monitoring features for an Oracle database, especially in this case for our autonomous database. And then, of course, we have already prepared an empty schema user to host our rock music table data. It is called rock user. We skip for this purpose 2 steps: the provisioning of an autonomous database serverless, and the creation of the user. We skip the steps, as in any case, you can find how to do these steps in the Oracle documentation, and we have also provided some links to share. Well, this should be ideally at the end the first level of our entity relationship data model. Here you can see the relationship between the tables. So at the top, I have the artists. But then, of course, what I also have the relationship between the concerts, the albums, the songs, the singles, and so on. Look, for example, at an artist performs in more than one concert and publishes more than one album. An album has more than one song in his albums, and so on. And look, these are the examples of one to many. We have here the examples of many to many. Given a concert, I have a set list associating the concert with the list of the songs for that concerts, and I have the songs of the albums recorded. So this is the implementation of our many-to-many relationship, for example, between concerts and the song performed in the concerts. Of course, this data model addresses a given stage of the data model that still needs a bit of refinement and extension. We have several ways about the table data loading. We use, as we mentioned, the database action tool options. For example, we use one of these is the SQL worksheet. The SQL worksheet is one of the most important one, because we do most of our steps there. And we can load data to create new tables, and even, as you can see for an example from one of the pictures, appending data to existing tables. Again, our source files which will be used to load data will be CSV, JSON, Excel file, and so on. Here you see, we can see other 2 ways to load the data. From the data tools, the set of actions from database actions, in which you can load files from local files, so for even cloud object storage. Okay, this once we have our table, our data populated and our data model created, okay, it's time to do some queries. We can create some reports, and we can even build some charts or dashboards. These are features that are included in our database action development tools functionalities. In this case, just to give some examples, I had already prepared some queries that which we created some charts. In some example here, you see in one example, the rock artist top performed songs. It is a query for which we mapped a chart that represents the most top performed songs for Jimi Hendrix in a given set of concerts. Of course, we are talking about a limited set of data. Okay, now it's time for the demo. So let's start and go to my database. So what you see here is the my SQL worksheet from the Oracle Autonomous Database Action set of tools that you can see here. I'm in the SQL worksheet. As you can see from here, I have already preloaded one table, the artist entity. And by the way, I've given naming convention policy. I will call all the tables rock_name of the entity. If I look at the table, just clicking, right-clicking with my mouse, I see the structure of my table. Okay, the data. Of course, I can handle some information here. For example, I want to order my artist ID. I just do some sort by right-clicking. I have my artist ID, and I can do this. Okay. I also have a primary key created, an integrity constraint already pre-created. This primary key refers to my artist ID column. Okay. Then we keep on. Now we load the other table data. So let's start with this. To load new data, I can just click this button on data load, or as previously mentioned, I can do via Data Studio set of tools for which data load. I will start for simplicity with these ones. They are very similar with just some slight difference. Data load, okay. Drag and drop, or simply loading the file. I will start with the albums. So loading the albums, then I need to do some, this is an Excel file. I need to do some settings before running the data loading. As you can see from here, you have a preview from the Excel file, directly from the Excel file. And you have, of course, all the structures that I already mentioned previously. So an already pre-created album ID identifier with reference to the artist's table. In this case, for example, we have some albums from Jimi Hendrix and this one from Led Zeppelin. And then we can have several features. For example, we can skip some rows during our loading. For example, we can see, okay, we can say I only want to load till 8 rows, only the Jimi Hendrix ones, for example. Oh, sorry, skipping, and so loading these ones. Or simply, we can limit rows to upload. That means I want to upload only the first 8 rows of my my Excel file. Just for example, in this case, I just do, at the moment, we, of course, load all the data. So we do next. Here you see what we are going to do. We are creating a table or appending to an existing one. We are creating a table. The table will be named Rock Albums. We have our column name mapping, an automatic mapping from the header of our Excel file to the column names. We just check that the column type will be mapped correctly. So a number for album ID, number for artist ID, and so on. And what I can do here, I can immediately create a primary key, okay, from here, and I do this. And of course, here you see all the rows that you've seen previously that are going to be loaded. So I have something like 23 rows. Okay, I can click on done and then run the job of data loading, or I do straight away from here upload, and I do upload from here. And here, something happened. Let's see. Well, let's see what happened here. We have some failed rows, so let's see what happened in this. By the way, the table in any case has been created by our albums. Before looking, going at the error, let's see what has loaded. So I just opened this table, rock albums. I have my structure created. I have my data. Let's see if everything has been collected. Yeah, I see just. Yeah, okay. I just see some of the albums created and so on, and I have all some of the information that are needed. Okay. Let's see the primary key. Okay, let's open again and let's see what we have. We have our data. We have our constraints. We have created the constraints built on our primary key, built on our our column. Album ID in this case. I can see, as you can see, I can see the information even from the other side. I mean, I open the edit, okay, from a given album. The edit means that I can change the structure of the table. So let's just see if it opens. Okay, it opens. So you can see the structure of the table here. Okay, you can see the primary key already created. I can in this case, what I can do, I can do some changes in my structure. For example, I don't like comment on album in my albums because the values in this column are the awards won from this for this album. So I can change the name of this column, and I call it album awards. Okay. Doing this, what I can see in SQL, from SQL standpoint, what I'm going to do. I'm renaming my column, but I'm doing graphically, okay? Apply this. Okay, it has been altered, and I have, if I just do a refresh, I have the name changed. Okay, let's move on to the other tables, then let's see. Okay, again, data load, albums, then let's see another one, the singles, okay? So let's load the singles settings again, because we need to look at the information. These are all the singles that I have collected, just part of the vast amount of data we have. We call the table rock singles, okay? In this case, I wait. I do not create immediately the primary key. I have the column name mapping, the column type. And let's see what we have. We have all the rows here about the singles I've collected from my Excel file. By the way, my Excel file about the singles is this one, okay? Think about someone provide me, sorry, this is the songs. Yeah, this one. Some guy provided me with an Excel file or CSV with some limited information, with some nulls, columns, and so on, and with this track, for example, okay? Just as an example, I do done or upload. This time I do done and I do the uploading. Okay, I created the table. Now it's good. And as you can see, I did not create immediately my primary key. Let's move on. Let me load another table. Let's say we have the concerts. Let's load the concerts. Okay. Settings. We do the same. I suppose for the moment, I would like to load only a certain number of concerts. Okay, so let's say for example, I want only to load the concerts for the artist ID number 1. So I go till number 27. So I limit my rows to upload. Okay, let's say 27, and I can do this. I do my next, because I'm creating a new table, rock concerts. Again, no primary key at the moment. Upload, and I'm okay. Now I say, oh, I forgot my concerts. I did not load. This is the Excel file. All the concerts by Led Zeppelin. Okay, let's do this. Let's do this at this point. Yeah, sorry. Data load again. Oh, sorry, not from here. Look, I'm at concerts. Okay, I can directly click here and do my data loading, uploading data. Okay, it's similar to data load you have seen, but what we have again, concerts. I look for my data source. Okay, and look, I already have the name of the table preset because I'm doing a loading to an existing table. But again, just let me do some settings. Why settings? Because I need to skip some rows, and I need to skip the rows already preloaded. FME are the rows till the artist ID number 1 till 27. So let's skip. These are the rows from the source Excel file. Okay, so rows to skip means for me that we start with the concert ID 28 for the artist ID 2. So this set of data, let's say upload, and we are okay. Now we have all the data for the concert data, and now we are okay. We have all of this. Okay, we just need to finish. So data load. We have the set lists, okay, and then the songs. Okay, settings. You see all the given a concert. I have the sequence, the relative sequence of the concert. Some information about the song name, whether it is a cover, and so on. So let's say next. We don't skip anything here. Okay, rock concerts, concert set list, the name. Okay, I don't create any primary key. Given the particular table we have in this case, and we do our upload. Okay, last one, songs. Let's go to the song. We do this. Settings, the song of a given album. Okay, we load all of them. This is the structure we are going to create. So number, album ID, and so on. In this case, let's see, rock songs here's the name. We can even change the column type here. For example, I can say, let's see, for me, it's a varchar 264, for example, this one. Let's say upload. Okay, now we have all this information. Just to provide you, we have the album, the artist, concert, setlist, singles, song, and so on. Let's look at database action at the moment. Let's look at some other information. The data modeler. You know, remember we are creating a data model. We have this this white blank diagram that we can put our data on. So we just drag our tables. Okay. For example, take this two. We have our artist that has already been pre-created and already with a primary key equipped. The albums with the primary key equipped. Okay. We have the concerts. For example, let's do this. Okay. And let's do this for a better view. We have the singles. Okay. We have the songs. We have the concert set lists. So let's put things together now. As you can see, these are tables that are still not related among them, okay? We need to create the referential integrity. So let's move and let's do this. I have my rock artist, rock albums, okay? I go via edit because I'm doing a data definition language change, okay? What I need here, I need a foreign key. I need to relate my artist ID to the artist entity and on the rock artist table or artist entity. So what I do a foreign key. From this table properties, I do a DDL, adding an integrity, referential integrity, and I call it foreign key underscore album artist. So from the albums to the artists. Of course, my table is the reference table. Reference constraint is the primary key for the rock artist. My local column is artist ID. And what is the DDL here? Is an alter table add constraint foreign key. On delete cascade, that means if I remove an artist from my database, I need to remove all the related albums. So to respect the one-to-many and the referential integrity. Apply. So I create this foreign key. I do the same now for the concerts towards the albums, towards the artists, sorry. So I edit the table structure of the concerts. What I don't have, still don't have, I don't have a primary key. I create a primary key, first of all. Primary key, concerts, okay. I use the concert ID, of course, column. I check my DDL, add constraint as a primary key. Apply. We open, we edit again the concerts. Okay, primary key. Let's create a foreign key now towards my artists. That means foreign key, concerts, artists. What I use, of course, my artist as a reference constraint and artist ID as my column. DDL, we already seen this. We do apply, close. Let's see how is changing my data model. Okay, this is my data model. In order to see some changes, I go to my interested tables for which I created the referential constraints. For example, I go to my albums. I right-click and I click some update, and the integrity constraints have been indicated in my chart, and it is described here. I have a foreign key and created my albums towards the artists with these reference columns. The same for the concerts. Okay, update. Okay, we keep on doing this kind of information. So artist, album, concerts. Now it's time for the songs towards the albums. Okay. Do I have a primary key? Not yet. I create it. Song ID, apply, and I'm okay. Then let me do a foreign key. And I create a foreign key from the songs to the albums. Okay, let's do this. That my table here are the albums. Okay. And I have my album ID. Apply again. So what we have now? I open my songs. Sorry. Open. Now, when I open, what I can do from the data definition point of view, I cannot change anything. I can only change my structures, by the way, only doing the edit, as you can see, as you have seen previously. Here, from when I do open of a table, I just can have a read of the read through the structure. I can have a look at the data. I can change some data value. This is some example of a DML I can do straight from this viewing part of a table. Maybe this love one, for example, I can write this one. Of course, it's not correct. I can comment. Let's say let's undo this this statement, this information, this change. But we were looking at the constraints. So I have a primary key and I have a foreign key created, foreign key towards the albums. Let's continue. What about the singles? I start creating at the moment. Okay, I need a primary key for the singles. Okay, it's my single ID, and I'm okay. Then I create a foreign key. At the moment, in my approach, I create a foreign key here towards the albums. And albums can have more than one single, if you remember. Rock albums, I have an album ID. Okay, apply. Now, just to finish, if you remember the relationship between concerts and songs by means of set lists that implements the many-to-many. So in order to enforce the many-to-many relationship, what I do in this way, I need to create in my rock concert set list table two referential constraints, two foreign keys, one towards the concerts and the other towards the songs. So here I do this. Foreign key underscore set list. I provide this name, and towards the concerts. That means my referential constraint is rock concerts, and I have a concert ID. Then I create another one. Okay, I can do twice. I can do more than one foreign key creation. And for me now it is foreign key set lists towards the songs. So now the referential constraint is on primary key of rock songs, and this will be the song ID. I do apply, and I have all the referential constraints created. Now I can see here from the rock concert set list, if I do my open, okay, I look at my constraint and have these two constraints created. How can I see them now on my database action data modeler tool? Well, simply, I go to each table, I do my update, and the referential constraints is created. Here. I'm doing the refresh, the update on the tables for which the referential integrity are created, okay? And songs. So, at this point, we should have finished our data model. Of course, as I told you previously, it is the first level of our data model creation, of our deployment of data. Everything can be changed, modified, improved, several ideas can be created more. But let's go 1 second to another part. I have some SQL. Okay, now we have some. We can use some SQL already ready in my device. I just taking something. As you can see, look at some of this. I already prepared some SQL example scenarios to be used as reports, and especially chart reports. As an example, look at this query. This query is the top performed songs in concerts by a given artist, Led Zeppelin. Maybe I have too few rows for this user, but just keep it for an example. If I do my query, I have this. I have given a song name, the number of concerts that has been that have been performed. Okay. Given this song, let's make another example so we have more data. Jimi Hendrix. Okay, let's see this. So we have more data to deal with. Okay, we have several songs that have been performed, and so on. Now, here I have the query result. I have the script. I want to have a chart. I have to have something more. If I go here, I can create a chart straight from the query that I have just run. So I do this. I create it as an artist top performed song. Okay, in concerts. Okay, I do this. This is the chart creation process. I will have the chart. I will even will have the data grid ready, and the refresh will be automatically when something changes. I go to next. Here, as you can see, okay, the charts needs to have a bidimensional construct. So for this reason, I have only song name as an as a dimension, and then the group, the aggregation function. In this case, I have the song name here. I give an access label, and I give the two axes the label name, and then I would say this: what I want to have, not an area chart, a bar chart, for example. I can have, okay, can be vertical, can be horizontal, okay, and I have something better. Here is the Cartesian, but given for this song, I would like to have a polar coordinate system in which I have this kind of output, for example. And if I do a create, suppose I create it, okay, I go directly to the chart and dashboards page of my Oracle Autonomous Database Action Tools. As you can see, I already created some of them, okay? And this one is doubling the other one we see here. But just to let you know how I came to this. I did directly from SQL. Once to a SQL, you create a chart, but you can reach the chart page directly from database actions, okay? And you see here, charts, okay? You go to charts, and you have all the charts you need here. So, for example, has already been pre-created this one, okay? This is similar to this one. I can look at it. If I go here, I can view the chart or edit. So let me view the chart. It's the same that we created as an example previously. In my case, for example, here you see Foxy Lady 12 times in concerts, in the overall concerts that I loaded into my tables, of course. And suppose I want to change anything, I go here, edit. I go to next. I don't need to recreate another query. If I want just to change something in my query, for example, now the artist name is not anymore Jimi Hendrix, is Led Zeppelin. Okay, of course here I'm skipping all the things about how to do a lowercase of the name. I'm skipping all the handling of lowercase and uppercase. And look, if I do a preview, okay, I have already the preview of what will be the result. I'm still using the polar, okay, but no one stops me to say, no, let's go via the bar chart, Cartesian, and let me do the preview if I have it, okay. But I prefer to have this one in my case, but you can choose, of course. I do save, otherwise it will not be saved. And now if I run it, okay, view chart, I have the ones for the Led Zeppelin, and well, for now I just have this song most performed in the concerts for which I collected the data. Okay, so we've seen something about the data model, the SQL, okay, the charts. Now let me go back to the slides. Slideshow, okay, from current one. Well, it's not finished. Just the last things. It's not finished because, of course, this is the Rockin experience on autonomous database and SQL is just a starting point, or we could say what we've done so far is we reached the end of the beginning. Other things now can be improved, open to new ideas to develop, to remodel, to change what is needed. So, for example, some ideas to enhance our environment and data model. These are the ones that I immediately thought about. We need to optimize some table structure attributes. We need to optimize our entity relationship data model, and to clean up some data columns, some attributes that are redundant between tables. For example, I have in my rock concert set list that is related to the set list only. Given a concert, the list of the songs, I don't need to repeat in this table the song name that I can catch from the can retrieve from the song entity or song table, and the venue. The venue is the location in which the concert has been performed, and it is in the concert event, in the concert table. Then songs, the songs of an album, and singles. In my entity relationship model, they are not immediately related between them. We don't have any kind of integrity referential constraints, but I have already prepared in my single entity a reference song ID, just because, of course, one suggestion could be let's directly relate the songs and the singles together. Making an example, I know that the single the single is for sure a song of a given album. Let's simplify. It's not always in this way, but let's simplify. But a song of an album not necessarily is a single. So we are already imagining a 0-to-1 relationship in this case. So my entity relationship data model can be improved, maybe relating directly the songs and the singles. Then some managing of my primary key columns handling. So, for example, I have all these tables. I have primary key created. I have unique values as per my manually collection and data loading. For the next data loading, it is better to have my primary key column well managed. So maybe associating with the sequence. Trigger that feed in a proper way the sequence once I create new records for my table. I can also have columns that are called identity columns. I mean, an identity column is a column that we're already having underneath a system-generated sequence, which guarantees the sequencing number of the and the uniqueness of my table. This helps me in not worrying about, maybe in an Excel file, having the artist ID column or even the album ID column, and so on. So this is another way to better to improve my table structures. For example, I can handle some columns as JSON. I mean, referring to my album awards column of albums table, since it is a descriptive column. I can structure better as a JSON. We are in 19C as per my assumption, and so we can create a check constraints on albums table. And for example, this kind of description can be: I have an award for this album, and I have a description of this award. The RIAA has been won as a multi-platinum twice for Jimi Hendrix in a given album, or for Led Zeppelin. And then I would say at the end also, let's dive into the low-code application development environment and build an Apex application on top of it once we have deployed our data into autonomous database. So what I can say, this is the starting point of the Rockin to SQL experience. Of course, we have seen just part of what we can do. So we can continue our Rockin journey by loading more data, refining the table column attributes and structures, reviewing the data model, and so on. So providing new suggestions and new extension on what we have built so far. So this is a starting point for this model extension, and encouraging also the use of autonomous database tools to load, to handle, to make charts, SQL, and so on. So for now, some useful links. We have a useful live lab, okay, then focusing on load and analyze, loading data into autonomous database. We have documentation links about provisioning an autonomous database, creating user on autonomous database, loading data, and so on. And then a link on Oracle database action tools that we are extensively used today. Another reference is for curiosity. We're talking about data model and how to improve a data model, an entity relationship and data model. The link to Wikipedia about third normal form. That is one of the optimizations we could go to. For now, what I can do is to thank you for attending me in this demo, in this video. Over to you, Maria.
Great. Thank you so much, everyone, for joining. And thank you so much, Paolo, for a great presentation and demo. And thank you so much, Sonja, for running the Q&A. Thank you so much again to everyone who joined. And we hope to see you next time and have a great upcoming holiday season. Thank you.
Thank you very much.